My name is Deepam Priyadarshi. My registration number is 19BPS1117 and this is my DA1 assignment. My topic is Relational Algebra. I have used PowerPoint slide to illustrate my ideas. So the topics that I am going to discuss in this presentations are a brief introduction on Relational Algebra. Then we will move on to unary relation operation, which will include select operation, project operation, rename operations. Then we will move on to operations from the set theory, which will include union, intersection and set difference and Cartesian product. And the last topic will be binary relation operation, which will include join operation. So let's start with the brief introduction of relational algebra. As we know that relation database management allows us to perform some set of operation on the relations that we store. So the set of relations are known as relational algebra. These operation enables a user to specify basic retrieval request in terms of relation algebra expression. So let us understand using a simple diagram. Here we have a relation from RDBMS model. We can perform relation algebra operation to get a certain relation, and we can again perform another relation algebra to get our final result. These sequence of relation algebra operations are known as relation algebra expression. So moving on to first topic, unary relation operation. As the name suggests, these relation operations are applied only to a single relation at a time. The first operation in unary relation operation we have is select operation. The select operation is used to choose a subset of tuple from a relation that satisfies certain given condition known as selection condition. This is a general notation of select operation, where sigma signifies the select operation. We have a select condition, which is a Boolean condition, and R, there's a bit note, we have to take a note about R, since R can be a simple relation of a database, or we can have a relation algebra operation whose end relation is a relation on which we are performing a select operation. Moving on to select condition. A select condition is actually a agglomeration of these three terms. We have attribute name and this select operator, conditional operators. Then we have constant and attribute name. So in select condition, we perform a comparison between attribute name and constant, or an attribute name and another attribute. We can also join two different selection condition using the logical operators and or not. Here is an example where we have joined two different selection condition using or operation, and the selection conditions even in turn have a different comparison operator and along with selection logical operator. There are some salient features of select operation which are to be noted. Degree of operation, by this we mean that the number of attribute in the resultant operation. In select operation, the number of attribute in the resultant relation is equal to the attributes present in R. The number of tuples in the resulting relation is always less than or equal to the number of tuples present in R. We should also make a note that the select operation is commutative, that is, the order of the select operation is irrelevant. We can perform the first condition, we can perform the second condition first and then the condition 1, or we can do it in the reverse manner. We can always combine sequence of select operation into a single select operation using the AND condition. Here we can see that there are sequence of n select operation, which we can equivalently write it as in this form using in a single select operation and combining all the condition using AND operation. So here we have an example. We have a relation named known loan, and we are performing select operation with a given condition that the branch name attribute value should be very right, and the output we have this relation having all the attributes of the relation loan, but and the branch name attribute has value very right in each tuple. The equivalent SQL query for the above example is select star. This means that we are projecting all the attributes of loan relation from specifies the relation name, and where clause specifies the selection condition. Here we have given branch name equals to very right. The next operation in unary operation is project operation. Project operation selects certain columns from the table and discards other columns. So if we want to project only certain attributes of a relation, we can do so by using project operation. This is general notation of project operation. The pi represents the project operation, and the attribute list are those attributes which we want to display to the user. And again, R is either a simple relation from the database or a complex relation algebra expression whose resultant is itself a relation. The salient features of project operation are the result of the project operation has only those attributes that are specified in the attribute list, and they are in the same order as they appear in the list. So the degree of the resultant relation is equal to the number of attributes present in the attribute list. The project operation removes all duplicate tuples. So the result of the project operation is set of distinct tuples. This is also very necessary because the relation database model does not allow to have duplicate record values. So this duplicate elimination is an important feature of project operation. The number of tuples in a relation resulting from project operation is always less than or equal to if the list that we have mentioned forms the super key of R. So if there's a condition where we have a list which is subset list 1, we have a list 1 which is a subset of list 2, and we are performing this operation, then we can equivalently write to this, because the final result will have all the attributes listed in list 1, which is a subset of list 2. So here's an example of project operation. We have a relation named customer. If we want to display only the name and city attribute, so we have a relation algebra expression. The resultant output is this. We have all the tuples since we don't have any select condition, so we are displaying all the tuples but only two attributes, name and city. The equivalent SQL query is select distinct. This distinct clause ensures that no duplicate tuples are being displayed in the resultant relation. And name and city are the two attributes which we want to be displayed from the relation customer. No where clause is given here since we are not performing any select operation. In this example, we have the same relation loan, but we are also performing a select operation. After that, we are performing a project operation. So first all those tuples are getting selected for which branch name attribute has a value very right, and in that relation we are only displaying two attributes, branch name and loan name. So the equivalent SQL query for the above will be the same, where we only add a where clause specifying the selection condition to perform the select operation. Next operation in unary operation is rename operation. This is generally used for renaming the resultant relation attribute name or both of them in a relation algebra expression. Generally, there are three forms of rename operation. The first form, as you can see, only renames the relation to S. The second form renames the attributes to B1, B2, B3, for example. third form renames both the relation name as well as the attributes name. So as we have seen this expression, uh, this is a composite expression of select operation and then project operation, which we call inline operation. These can be very big and very difficult to understand, so we use a technique of breaking down into its sequence and renaming those intermediate relation to some temporary names. Here we have given the relation name temporary. Here we are given the name temporary to the relation which we get after performing the select operation on loan. Then this temp relation is used in the second operation, project operation, and the final relation is named as result, which is displayed here. So we can also do the renaming of attributes and as well as relation. Here we named temporary as the relation that we got from the select operation. This temp relation is used in the project operation, and here we have renamed the entire relation as well as the respective attribute name to b underscore name and l underscore name. The output you can see here, the attribute names has been changed as compared to this one. This is another example where here we have written the same expression in a single inline expression. The equivalent SQL query uses the aliasing operator as, which gives an alias name to the relation name L as L. It can be also used to change the name of the attributes as we have used here. The where clause specifies the condition for performing select operation. The next topic is operations from set theories. So relational algebra also allows us to perform some operation from the mathematical set theory. It includes union, intersection, and set difference. So the first one is union. It is denoted by R union S. The result of this operation is a relation that includes all the tuples that are either present in R or in S or in both of them. Duplicate tuples are also eliminated. So for performing a union operation between two relations, the relation must be union compatible. By union compatible, we mean that if there are two relations R and S, if they are of the same degree and the attributes domain are same, then the two relations are said to be union compatible. Union operation is commutative and associative. So here is an example. We have two relations, student and instructor. We perform a student union instructor operation, and as you can see in the resultant relation, we have all the tuples of student relation as well as the tuples of instructor relation. The equivalent SQL query for the previous one is shown here. Here we perform union operation between two relations. The two relations are formed by these statements: select star from student and select star from instructor. These two relations are then joined by union keyword, which performs the union operation. The next topic is intersection. It is denoted by R intersection S, and the result of this operation is a relation that includes all the tuples that are common in both the relation R and S. As usual, the intersection is also commutative and associative. Here also we have two relations, student and instructor, and we perform a intersection operation, and in the result you can see that only those two tuples are being displayed which are common to both the relation, that is Suzanne Yao and Ramesh Shah. So the equivalent SQL query would be, there's a keyword intersect to perform the intersection operation in SQL between two relations. Minus. This is denoted by r minus s. The result of this operation is a relation that includes all the tuple of r which are not in S. So, and one more important note we should make here, that minus operation is not commutative. So in this example we can see this property, that minus operation is not commutative. As we perform a minus operation, student minus instructor, we get a relation which contains all the tuples that are present in student but not in instructor. But if we perform a minus operation, say instructor minus student, we get another relation which contains all the tuples that are present in instructor but not in student. Also, you can see here that the attribute names are those of the instructor relations. The next topic is Cartesian product. Next operation is not Cartesian product. This set of operation produces a new element by combining every tuple from one relation to every other tuple in another relation. So if we have two relation with n number of tuples, n number of attributes, and another s relation with m attributes, and we perform a Cartesian product operation, we get a resultant relation Q having n plus m attribute. But the number of tuples here would be, suppose we have k tuple in R and L tuple in L, so the number of tuple in the final result will be k into L, k times L. This is evident in this example. We have two relation, employee and department. Here we have performed a Cartesian product operation, and the final relation contains 5 attributes, which is 3 plus 2, 5 attributes, and the number of tuples are 3 into 3, because we have 3 tuples in employee and 3 tuples in department. So we have in total 3 into 3, 9 tuples in the resultant relation. So next is we have the equivalent SQL query for the above. Actually, we have two equivalent forms of SQL query. That is, we can use cross join keyword to directly perform a Cartesian product operation. Next, we can use a join without any where clause. This will also give a Cartesian product operation. So the next topic is binary relation operation. As the name suggests, these are always performed on two different relations. Join operation. Join operation, as denoted by this symbol, is used to combine related tuples from two different relations into a single longer tuples. So what this means is it combines tuples from two different tuples with a given condition. Suppose we have this R as one relation with n number of attributes, and another relation S with m number of attributes. So if we perform a join operation with given join condition, we get a Q relation named Q with n plus m attribute, but only those tuples will be displayed in the final result which pass the join condition. So here we can see that there's equivalency between these two sets of operation. Here we have performed a join condition of a join operation, and here we have performed a Cartesian operation, and after that we have performed a select operation with certain equivalent select condition. So these two operations are equivalent to each other. Moving on to the types of joins. The joins are basically divided into two broad categories: inner join, outer join. Inner join are those which join two tuples according to join two tuples according to a certain condition and display only those tuples which pass those conditions, whereas it is not the same in the case of outer join, where all of the tuples of one or either both the relations are displayed. In inner join we had theta join, equi-join, natural join, left outer join, right outer join, and full outer join comes under outer join. So in inner join we have first theta join. So when join operation is performed using any general joining condition, say theta, and using these as the joining as the conditional operators, it is called theta join. This is the notation for theta join, where theta being any join condition. So let's take an example. We have two relation named student and subject. We perform a join operation with given join condition where student's std attribute value must be equal to subject's class attribute value. So this is the final result, where we can see that the student and the std attribute value are always equal to the class attribute value, and only those tuples are displayed for which these conditions are being satisfied. Like like here we can see that this last tuple has no matching condition in subject relation, so there's no join operation for this last tuple. The equivalent SQL query would be select star, since we are displaying all the attributes name, and from student join keyword is used to join two relations, student and subject, and this is the joining condition written in the where clause, where student std attribute value must be equal to subject class attribute value. Next topic is equi-join. So when join operation is performed using equal to as the only conditional operator, it is called an equi-join. So the previous example which we saw was also an example of equi-join. The equivalent SQL query would be this: select star, from join keyword is used to join two relations, subject and student, and the where clause to specify the joining condition. Next is a natural join. So in the previous case, we can see that there are two attributes having displaying the same values two times. So one of them is superfluous irrelevant data we don't want, because it is taking up useless space. So this can be removed using natural join, but the standard definition of natural join is different. It is represented by an asterisk mark, and it requires that the two join attributes or each pair of join attribute have the same name in both the relation. That particular attribute is termed as join attribute. If this is not the case, then renaming operation is applied first. Suppose here we have two different relations, student and subject. Here we can see that the std of student and class of student can be used as joining attribute, but since we don't have the same attribute name, we have to perform a rename operation. So here we can see that we have performed a rename operation which changes the attribute name of the student std to class, which forms the join attribute for the natural join operation. And here we have performed a natural join between subject and the resultant relation of this operation. Here we can see that here only one attribute is displayed, unlike the previous where two attributes displaying the same value where they're in the relation. So the equivalent SQL query would contain a natural join keyword which perform the natural join operation. Here we where I have used as aliasing operator to change the attribute name std of the student to class, and where clause specifies the joining condition. Now we move on to outer join. The first topic in outer join is left outer join. Left outer join is represented by this symbol. This operation keeps every tuple in the first or the left relation R in the expression R left outer join S. So if there is no matching tuple found in S, then the attributes of S in the join result are filled with padded or null values. Let's take an example. We have the same student and subject relation. We perform a left outer join with this as the joining condition. Here you can see that all the tuples of the student relations are displayed, and for those tuple for which the joining condition has passed, or or there's a matching tuple in the subject relation, and it is being displayed in the final result. But since this last tuple doesn't have a matching tuple in the subject relation, null values are displayed here. The equivalent SQL query would be like this. The left outer join is the keyword to perform left outer join operation with this as the joining condition. Right outer join. The right outer join operation keeps every tuple in the second or right relation in the right outer join operation. If no matching tuple is found in R, then the attributes of R in the join result are filled with padded or null values. So here's an expression of right outer join. Here you can see that all the tuples of the right relation, that is S, are kept, and for those relations which have a matching tuple in R, the values are displayed in their respective attributes, but for those which doesn't have, none values are displayed in the attribute values. So the equivalent SQL query of the above operation is displayed here. The right outer join keyword is used to perform right outer operation, and where clause specifies the joining condition. Full outer join. This operation keeps every tuple in both the relation R and S in the expression R outer join S, full outer join S. If no matching tuple is found in R or S, then attributes in the join results are filled with padded or null values. So this is an expression for performing full outer join. Here in the resultant relation, we can see that all the tuples of R as well as S are displayed, and for those which doesn't have a matching tuple in either of the relation are displayed with null values, as you can see here. The equivalent SQL query would be select S, and we would use full outer join keyword to perform full outer join operation with where clause specifying the joining condition. So that's all from my side. Thank you.